This is our context-free grammar. As you can see, our program is made up of a list of statements, right? And a statement consists of an expression. A statement is either a print statement or an expression statement, and a print statement consumes an expression. Similarly, an expression statement consumes an expression. So it's kind of like a semantic rule of our grammar that wherever we are writing expressions, we are not allowed to write statements. Matter of fact, when we get to parsing statements, we are always consuming the underlying expression. That's it. Another rule, now we get to another rule of our semantic grammar. The other rule is that statements are going to be of two types, declarations and regular statements. So in the previous video, we solved till expression statements. So we can now go to variable statements. In this stage, we'll add support for declaring variables using the var statement. So we get another type of statement that is used for declaring variables, hence the name declaration. For this, you'll need to add support for the var declaration in your AST generator, parser and interpreter. And since we are adding something to the parser, that means we need to update our context-free grammar. All right. So the rule for declarations is wherever we are allowed to write declarations, we are also allowed to write any other statements. But the vice versa is not true. Let me show that to you. Let me show what I mean. So in here, so if right here I can write anything, I can print anything, but see, this is an expression statement. This is a print statement or an expression statement. But right here, I'm not allowed to declare variables. As you can see, if I hover over it, it shows declarations not allowed here. So wherever there are declarations, we are also allowed to write other statements. But the vice versa is not true. There are places where I can write regular statements, but not declarations. So this is one example. The other example would be a for loop or a while loop. So wherever you can omit curly braces to simply write an expression, you cannot write a declaration there. That is because a declaration must be bound to a scope. So whenever you create curly braces, you create a scope and then the declaration inside of it. That would mean that the variable is then bound to that scope that was declared in the curly braces. That's why variable declarations come inside of curly braces, but we're going ahead. Let's just come back. Let me show you what we're going to do. So they need us to add variable declarations to our parser. To do that, I will update our context-free grammar. This is what we have right now. I'm going to update it to look something like, so instead of statements, I'm going to have declarations because it's a higher level abstraction over a statement. Like I told you, anywhere we have a statement, we can have a anywhere we have a declaration, we can write a statement, but not the vice versa. That means declaration is a higher level. Declaration is a higher level of abstraction. Anyways, declaration is going to be a var keyword. So declaration is going to be again now of two types, a variable declaration or it may just be a statement. So a declaration may be a statement, but a statement cannot be a declaration. That's what this means. And a var decl looks something, and a var decl looks something like this. It's going to have a var keyword. Then it's going to have an identifier for the variable name. And optionally, it may be followed by an expression that is its initial value. So when we declare a variable, we also have the option to initialize it, and that's what this expression will do for us. This will give us the value, but this is optional. We may declare variables, and variables without initializers will have default values. So this is what a var decl statement would look like. And if you're adding variable declarations, we also need a way to be able to access those variables. So whenever we create a variable, we're going to store it somewhere, and then we're going to use it somewhere later in the program. So I need syntax to be able to access variables, and that is simply the name of the variable. And so our primary is going to also be an identifier. So if I see an identifier, I immediately know that I need to access a previously declared variable, and I will access it from some hash map or something. I will store the initial value against the identifier in a hash map, and whenever I see identifier in the primary, I'm going to access the hash map and provide the value. But that's it for the context-free grammar. So the example I showed you, like if, and inside that if I have a variable declaration. So we are not going to handle that right now. We're not there yet. We haven't added if statements and for statements yet. But when we do, we will make sure that their code branches cannot have single variable declarations. So with this, we need to make our parser compliant to this grammar. Since we added a variable declaration type of a statement, to our context-free grammar, we need to make a variable declaration type of a statement class. And that's going to be right here. I will create a new class called var decal. Arey yaar, what happened here? Sorry guys, I wasn't looking. Var decal, and it's going to extend statement. Doesn't exist yet. Let's add it to the statement visitor. Visit var decal. And since we added another terminal to our primary uh, in our context-free grammar to access variables, we will also need to create a node that denotes that terminal rule. So what we'll do is we will also create an expression, and it's going to be of type variable, and it's going to extend, you guessed it, expression, and visitor dot visit variable with this, and let's create the method. So in our variable declaration, what does the rule look like? Let's check the rule. A variable declaration is a var keyword followed by an identifier and optionally an initializer expression. So we definitely need to store a token, that's going to be the identifier, and we need an expression, and it may be null but it may also not be. So in our var decal, we're going to have a private final token of type token, and I'll call it name, import it, and I'm also going to have a public final expression, and it's going to be called initializer. Let's create a constructor. That's it. And in our variable is just a single token name. It's just an identifier. So all I need is a public final token name, import it, create a constructor. Now let's look at the example they have given us. They've given us this. So they're creating a variable and then accessing it. That means we need a data structure to store variables so that they can be accessed later on in the program. So the canonical implementation of interpreters use a data structure that's known as the environment. So it's just basically a hash map, and it's kind of linked with each other, a list of hash maps kind of. So we will store the value of the variable against the token that is going to be its identifier, and we will evaluate the expression and store it against the token in the hash map. So we need to create that data structure. So let's do that. We're going to create a class called the environment, and we are going to create it in the analysis package. Environment. So in the environment, like I told you, it's just a hash map essentially. Private final map of string to object. I don't know the value. It may be anything. Values, new hash map. And I'm going to create a few helper methods. So I'm going to create a void define method, and it's going to take an identifier and a value and store it against the identifier in the hash map. So values dot put name comma value, and I'm going to create a method from our hash map. So object get of token name, and if our map doesn't contain, we're going to throw an exception, and if it does, I'll simply return it. So if values dot contains key name dot lexeme, in that case I can return values dot get of name dot lexeme. Otherwise, throw an exception. Which exception? Interpreter exception. We already have it. And the error is, let me show you why I'm doing that. If you see the next stage, so this is the error that's expected of us. Undefined variable. So let me throw that for you. So throwing this exception right here will handle that for us. So this is our environment data structure. It's quite simple right now, but it's going to get complex later on. Now, since we updated the expression visitor, we need to update our AST printer. So our AST printer is right here. Let's add the node, add the method, visit variable, and the visit variable is going to be quite simple. It's just let's just return a grouping. Return parenthesize, and I will parenthesize. It takes an expression, so I will variable comma variable I think that will work. That's it. I think that should be fine. And we should also enable our parser into parsing the new statements and expressions we just created. So let's go to our parser now. Where is the parser? Parser. And inside of the parser, let's implement the okay. So let's look at our context-free grammar and see what we need to do. So our program was first going to a statement, but now we need to go to a declaration. So we start parsing right here. So parse program. Instead of statements, it's going to go to declarations. But it doesn't exist yet. I will create it. And inside of the declaration, let's look at the rule. So a declaration may be a variable declaration or a statement. And how do we decide if it's a variable declaration? We know it's a variable declaration if it starts with the keyword var. and we already have a method to check that for us. We have this match current token method, and like it's checking for print statement, we're going to check for var keyword in here. All right. So if we match the current token to be a var, in that case we know we have a variable declaration. Otherwise, we have a statement, regular statement. Okay, now let's create the var declaration method. In the var declaration method, we know we had a var keyword, and since the match current token advances ahead of the token, we are already at the identifier. So let's grab the identifier. We know an identifier is going to be a primary. We added that to our rule, but we haven't added it to the parser yet. So we'll do it right now. Variable, and let's go to primary. So this primary right here, let me remove this. So how do we know if it's a identifier? Our tokens have the type identifier in them, so we can, just like we've been checking for everything else, we can check for an identifier, match current token to be of type identifier. If that is the case, then I can return a new, we created an expression variable, so we will use it, and we can get the previous token through the previous method that we created earlier. All right, so now this variable that we are returning from right here will be caught in here. That's this variable is going to refer to the thing that we are returning from right here. So we have a reference to it here. We can get the token, the name of it, through var.name. We have that in the variable, and we know the initializer for it may or may not be null. So let me just initialize it with null, and if we so we know our identifier, if followed by an equal to, then it's also going to have an initializer. So I will match the current token to be of type equal, and if that is the case, then we know that initializer is going to be an expression that will be after the equal to. But if that is not the case, the initializer will be null. Okay, so all our statements are ending with a semicolon, so we are supposed to consume it as well. So we'll consume it right here, and after that we can finally return a new var decal and pass it the name and the initializer. So with that, we are done with the parsing, but we updated the statement visitor, so we will also need to update our interpreter. So let's go to the interpreter right here. You see we have some methods to implement. But before we do that, let me clear this visit variable and what visit variable declaration. Okay, so before we do that, before we implement, we go to the interpreter and implement it. Let's think about error handling a bit. With regular expressions, it was fine to break control flow if the expression had some error. So if our expression is an algebraic expression, it's fine to break if the only thing we're supposed to parse is an expression and the expression itself is wrong. So we might as well just break the control flow. But not with statement. That cannot happen with this context tree grammar because our program is a list of declarations. All right. So if the first declaration fails, doesn't mean the next declaration is going to. Maybe the variable in the first declaration is never used. Our program is still good to run. So in that case, we should not stop the control flow of the parsing. I, as an end user of a programming language, want all the parsing errors upfront when I compile my program. But if we stop the parsing whenever an error occurs, all the errors won't be thrown. So if my current statement has a parsing error, I should start parsing the next statement. That means I should move my pointer ahead till the current erroneous statement's end. And what marks the end of a statement? A semicolon. So we should skip all the tokens till we encounter a semicolon, or till we know that the next statement is going to begin. All right. So we should skip all the tokens till we see till the beginning of the next statement. So that's what we're going to do right here. So our declaration may have errors. Try. And if there are, then I'm not going to throw an error. I'm going to call a method called skip. Wait. I'm going to call a method called skip current statement. And what it's going to do for me is it's going to skip all the tokens that are part of the current statement. And after that, I can return null, for no declaration was constructed right here. All right. So let's create this method. And in this method, I'll advance. And I will keep on advancing till I'm not at the end. So if the previous dot type is a semicolon, then we know we are at the end and we can return safely. And right here I can keep on advancing. I told you that semicolon will mark the end of a statement, but there are other cases where a statement may end or a declaration may end. Can you guess that? What kind of statements do we have right now? We have a print statement and we have expression statements. But are there any other type of statements in a programming language? Well, there are if statements, for statements, variable declaration statements, which we already have, a return statement, a function declaration, or a class declaration. So, if after advancing once, we see that a new variable declaration is starting, or a new for loop is starting, or a new if condition is starting, or a new class is starting, in all those cases, we have actually come to the end of the current statement. We are now at the next statement. And I want to parse the next statement. I do not want to skip over it. So I don't want to advance over it. So whenever I encounter a var statement, a for statement, or an if statement, or a print statement, or a return statement, or a class, or a function, in all those cases, I want to stop this while loop. And we can do that by returning like we are for the semicolon case. So I will switch on the current tokens type, and if it happens to be of type class or a function or a variable or a for or an if, my bad guys, sorry, or an if or a while or a print or a return, class, function, variable, for, if, while, print, return. In all of these cases, I want to stop skipping the tokens, and I can do that by returning from there. All right, that completes our parser. That's all we need to do to our parser. I hope you understand what I meant with this. Let me show you what I mean. So if we have an erroneous statement right here, but it's being followed by a for loop. Then we know we are, if my pointer is right here, then even though this statement was erroneous, it doesn't mean that I am not going to scan the next statement. So if I see a for, in that case, I want to stop skipping tokens. That's what this means. Anyways, now we are good to implement our interpreter. We already have these methods here, var variable declaration. So let's implement the variable declaration. So a variable declaration, a variable that is being declared may or may not have a value. By default, let's say all the objects will have a value of null. So this will be the value for our variable. And if it has an initializer, if var decl dot initializer is not equal to null, in that case value is going to be var decl dot initializer dot accept of this. That's the beauty of visitor pattern. So we know the value of the variable now, but where are we going to store it? I told you we're going to store it in an environment. We already created the class of the environment, but we didn't initialize it. So let's initialize it right here. One interpreter is going to have one environment. One environment env equal to new environment, and the variable we just declared will be stored in the environment. We have the define, and it will take var decl dot var decl dot, it's going to be public var decl dot name comma value dot name dot lexeme, and now it's stored in the environment. I can simply return the value as well. Return var decl, oh sorry, my bad, value. This will store the value against the name of the initializer in the environment hash map. I just need to get it now in the visit variable method. So in here, environment dot get of variable dot name dot lexeme. Oh, it just takes a name. And that's it, guys. That's all we need to do, but it's throwing some error. Let me see what that is. What's the error? Missing return statement. Oh, that's all. Let me show you that it works. Let me copy their example. So the example we have is this. Let me print it. See, it works. Let's try and push it. Variable, we declare a variable. Tests are running. Tests passed. Let's move to the next one. I'm ranked 17th on the Java leaderboard. Oh damn. This is where I am. Oh hey guys. Haha. I have 2835 points and I've done 108 stages. Oh, I have a lot to catch up. Anyways, So view the next stage. That also passed. Let's move on to the next one. Initialize variables. We are already doing this. We are already setting a default value to be null, and redeclaration of variables. What's required of us here? So if a variable is, yeah, so if actually, so yeah, that's a good point. Logs wants us to redeclare the variables, and we are not checking if a variable already exists in the environment when creating, right? We have this define, but we're not throwing an error in that define in any case. Where is it? Where is our environment? So in here we're just putting, so we are overriding the value, we are redeclaring. So that's also good. So with that, we complete variable declarations and declarations in general. Uh, that's it for this video, and I'll see you guys in the next one.